Okay, in this video we want to look at a slightly different form. Notice that we have the limit as x approaches infinity of 1 plus 1 over x quantity to the x power. And if we were to plug in x equals infinity, the 1 over x would become 1 over infinity, and that would basically equal 0. And so we would have 1 to the infinity power, which is one of our indeterminate forms. But this type of indeterminate form, when we have 1 to the infinity, or 0 to the 0, which we'll look at next, the way we deal with these is we assume that the limit exists and we set that equal to y. So that's always the first step in this type of problem. Then we're going to take the natural log of both sides. And the reason we do that is that that's going to allow us, by the properties of logs, to take that x in the exponent and write it as a multiple of the natural log. Then, when we plug in infinity now, we're still going to get infinity times 1, which is not one of our indeterminate forms, but we could simply rewrite this, infinity times 0, which we know infinity times 0, the way we deal with that is we rewrite it in the form of infinity over infinity. And we do that by, instead of writing x, we'll do 1 over x. And now, when we plug in x goes to infinity, we'll get 0 in the denominator and 0 in the numerator. And so we'll get 0 over 0, which is now an indeterminate form that allows us to apply L'Hopital's rule directly. So we still have the limit notation. Then we're going to take the derivative of the numerator, and the derivative of ln of anything is 1 over anything times the derivative of the anything. And the derivative of 1 plus 1 over x is negative 1 over x squared. So that's the derivative of the numerator, and the derivative of the denominator is simply negative 1 over x squared. And fortunately, the negative 1 over x squared in the numerator and denominator cancel, and we get the limit as x approaches infinity of 1 over 1 plus x. As x goes to infinity, we're going to end up with 1 over x being 0, and leaving us with 1 over 1, which is 1. You have to be careful at this point. This doesn't mean that our limit is 1. It means that ln of y is equal to 1. So that tells us that ln of y is 1, and when we exponentiate both sides, the natural log of e is equal to 1. And that tells us that y, which is the limit as x approaches infinity of 1 plus 1 over x quantity to the x power, is just e. So this is actually the limit definition of the constant e. Alright, but this shows us how we use L'Hopital's rule to evaluate a limit like that, and a limit that's in the indeterminate form of 1 to the infinity. Okay, that'll do it for this example and this video.